Last week, the IROS 2022 conference was held in Kyoto, where thousands of roboticists from around the world gathered to show off their achievements and share their most incredible developments. We've selected the most interesting robots and award-winning research from IROS 2022 in today's one episode, so fasten your seatbelts and let's get started. What do you think social media will be like in the future? On the screens of our smartphones, social networks have long been familiar and occupied the first positions on the main screens of gadgets. But technology does not stand still, and soon, perhaps the usual applications for communication will change beyond recognition. Metaverses and social networks. What will come of this combination? Could you imagine you could have several bodies that you could use in parallel, and any way you want? It will be possible very soon. There's already a large team of developers working on the Blackmagic application, which will soon be available on your smartphone. This app will allow you to scan your body using integrated scanners in a matter of seconds, and then improves or completely change your digital body according to your preferences. Or go to the marketplace and just choose any other real or fantasy body. It can even be an Instagram model or famous athlete. Yes, there is one thing. Choose as many bodies as you want, and then you can use them according to your needs. Meet friends, create video and phone contests, go on dates, use your favorite avatar bodies on other platforms, games, and messengers. Are you a famous influencer or just a person with a bright appearance? You'll be able to scan yourself and upload your body to the marketplace. Let modeling agencies, film companies, brands, and general users use your avatar according to the usage policies you specify. The developers also plan to introduce the application economy so that everyone can earn more on it. The company aims to directly compete with Google, Apple, and Meta in selling personal data, except that Blackmagic's vision is to do so openly by paying its users every time someone wants to use their data. To this end, they'll create a digital twin that will be used by all VR, AR, MR devices and will be the first on the Qualcomm Spaces and Metaverse platform. So, if you're a creative person, then create bodies using simple tools and earn money on every download. Perhaps you're a designer and you already have a personal collection of clothes or accessories. Then you're here too. Write in the comments your opinion about the Blackmagic project. Would you like to become a user now? The Dialog robot from Nagoya University. One of the highlights of every IROS conference is the competitions. This year's competition among the creators of Dialog robots attracted a lot of attention. The winner was a team from Nagoya University which developed the most human-like conversational robot. Eco-friendly robots for environmental sensing, EMPA Robotics. The EMPA Robotics unveiled their own in-house designed environmental sensing and manufacturing robot at the conference. The team uses biodegradable materials in creating the machines and offers multimodal robots capable of sensing the environment, triggering in certain circumstances, and at the same time having minimal impact on the environment. Also, EMPA Robotics has similar robots for underwater work as well. Developers are exploring soft robots capable of adapting to unstructured real-world environments and aerial robots for maintenance and repair. The Scalar Climbing Robot from the University of California at Los Angeles. Developers at the University of California in LA have demonstrated the universal climbing robot Scalar from Romella Laboratories at the conference. This four-legged robot can climb rocky walls, protrusions, ceilings, and trot on the ground. Scalar is one of the first four-legged robots with a high degree of freedom to climb freely under the action of the Earth's gravity, and one of the most mechanically efficient quadrupeds on Earth. Where other modern climbers specialize in climbing, Scalar promises practical free climbing with payload and ground movement, making it versatile. The robot can move on the ground at 0.56 meters per second and climb walls at 0.35 meters per second. The payload reaches 233% of the Scalar's weight on the ground and 35% on a vertical wall. The Guardian Robot by Riken. Japanese research institute Riken presented the Guardian Robot project at IROS 2022. It aims to develop software as well as a central recognition and interaction mechanism for robots of various configurations. The ultimate goal of the project is to create a robot that can coexist with you in your home for years to come, supporting us when we need it and not disturbing us the rest of the time. Researchers call it the backstage support, or the Japanese word sarengenai, which can roughly be translated as random support. And by the way, what kind of support robot shape and appearance would you like to have in your home? Let us know down below. The VR-based telepresence system DLR Institute for Robotics and Mechatronics. The Institute for Robotics and Mechatronics at the German Aerospace Center has demonstrated an unusual telepresence system, and its differences are not only in the fact that it uses a drone and manipulator as a robot, which can approach an object regardless of the surrounding landscape, but the key innovation is the fully onboard perception system, which creates a virtual reality of the robot's workplace in real time. And in doing so, the operator can not only sense objects using force feedback, but also receive three-dimensional visual feedback about the drone's environment. To make this happen, several sensors are used, namely LiDAR cameras and IMUs. They process the received sensor data. Algorithms are developed to estimate the shape of the object, drone position, active learning of the system, and more. And once all of this combines, it allows it to perform tasks at day or night, winter or summer, with a 70% guarantee of success. What do you think of this? Reflexive Robotics, CVSSP Robotics Lab, and Surrey Institute of AI. The CVSSP Robotics Lab and Surrey Institute for Artificial Intelligence, both focused on intelligent perception for robots, spoke at the conference about their work. It's true that no specific results were presented, but the topic itself is interesting. Researchers are engaged in the development of a system that can not only see and hear, but understand the world around them, and also act on the basis of knowledge. Its specific example would be work in reflective robotics, with the goal of making the robots respond instinctively to humans. This would reduce the reaction speed of robots and make them much more useful for applications such as healthcare or tourism. It's a big and interesting problem, so we wish them success in their research. By the way, you'll find links to all the research from the issues, and you can find that in the description. ECLT-VIO, University of Zurich, and ETH Zurich. The Department of Neuroinformatics at the University of Zurich has unveiled a new position tracking system for planetary helicopters, like Ingenuity, only better. Today, event cameras are considered the best available sensors for vision-based exploration in future helicopter missions to Mars. But existing event-based visual inertial odometry algorithms either suffer from severe tracking errors or are unstable because they can't handle significant depth uncertainty. So, researchers from Zurich created ECLT-VIO, a system that eliminates both limitations by combining a state-of-the-art external event-based interface with an internal filter-based interface. This makes it accurate and robust to uncertainties, outperforming existing algorithms on complex tests by a whopping 32%. You can find out more at the link in the description. Drone adaptation on the fly, University of Zurich and ETH Zurich. The Department of Neuroinformatics at the University of Zurich also presented another interesting work on the quadcopter movement, but it's on the ground. The researchers solved the problem of controlling a drone online when the environment changes or it encounters unknown disturbances. The problem is complicated due to the fact that creating time-optical trajectories that take into account the full dynamics of the quadcopter requires significant computational resources and, thus, time. The developers have presented a combined approach that combines trajectory generation methods with contour control and model prediction, so the drone can adapt to external changes quite literally on the fly. So far, the algorithm works reliably at 60 km per hour on a racetrack with moving gates and successfully adapts the drone's trajectory in strong winds of up to 68 km per hour. Robotic telecontrol with collision avoidance from Apptronik. Apptronik, a robotics company from the United States, presented effective VR control of humanoid robots' upper body with collision avoidance at IROS 2022. A bit of a problem is that when you control the robot, you walk the same way it does. But this information may not be enough to avoid sudden collisions with people near the robot. Apptronik's method is to reconfigure the off-the-shelf virtual reality ceiling trackers that allow you to enable collision self-prevention as a part of the inverse kinematics. This will allow the robot to not rely solely on an operator to avoid collisions. And again, more details in the description. Optimizing robot motion without splashing, Technical University Munich. And the Technical University of Munich presented a development to optimize the trajectory of a robot without spitting liquids out of a glass. Although the first association with the robot is a bartender at Oktoberfest, in fact, the developers are trying for elderly care applications as well. It's interesting to point out, the developers drew inspiration from the 300-year-old tradition of carrying cups of tea in Morocco, where practicing superhuman high-speed movements allow it to not spill a single drop even when the glass is absolutely full. Autonomous navigation over unknown terrain, Robotics Systems Lab, ETH Zurich. Robotic Systems Labs of the ETH Zurich presented at the conference its algorithm for robots on their feet when navigating autonomously in an unknown environment. Ideally, a robot would sense and analyze the terrain around it, evaluating information on risk, energy consumption, and time required to cross that terrain. To avoid manual control or programming, engineers suggest gathering information about the robot's traversability and movement policy by simulating the traversal of randomly generated terrain using a physical simulator. Thousands of robots are simulated in parallel and controlled by the same locomotion policy used in reality to gain 57 years of real-world locomotion experience in just a few hours. The effectiveness of the proposed prediction network, as always, is demonstrated on the animal robot. Motion planning for reconfigurable bases from Robotics Systems Lab, ETH Zurich. Robotics Systems Lab also presented the system it developed to design and plan motion for reconfigurable robotic bases. The problem is that for real-world applications, a robotic platform must satisfy two conflicting requirements: to have a compact base for moving around cluttered rooms and a large enough base to prevent falls and toppling during rapid manipulation with heavy loads. You can see the engineer's design solution right here on the screen. Adapting to soil properties for an excavator from Robotics Systems Lab's ETH Zurich. The same lab also showed at the conference the achievements of its robotic excavator, which now knows how to adapt to its movements and power independently to the varying hardness of the rocks when excavating. Soil properties are difficult to predict and can vary even within a single scoop, requiring a controller that can adapt to the changes in real time. The goal of the study was to fill the bucket with soil without breaking the machine or stopping work, and the solution was reinforcement learning. TumbelBot robot. Also seen at IROS was the TumbelBot hybrid bionic spherical robot. The millipede receives feedback from its growing tentacle legs and plans for further movement. As you may have guessed by now, the robot is designed to explore other planets. SpeedFolding, the University of California at Berkeley and the Karlsruhe Institute of Technology. The IROS 2022 award for Best Publication went to SpeedFolding's work teaching efficient bimanual clothing folding from the University of California at Berkeley and the Karlsruhe Institute of Technology. The researchers accelerated a process that is almost beyond capabilities of today's robots by using an intuitive approach. The idea is that the robot was first taught to straighten things so that they can take the shapes it understands and then use given instructions on the folding lines. In order for the robot to do anything, it had to be shown 4,300 examples of human actions, and believe me, 120 seconds to fold one piece of clothing is a huge achievement for a robot. Gesture-to-Vec, Simon Fraser University. Also on display was Simon Fraser University's cognitive robotics work. The Gesture-to-Vec system is a model that allows robots to self-generate natural and human-like gestures in dialogue with live humans. RCareWorld, Emprise Lab. Emprise Lab presented the RCareWorld simulation system, which also won an IROS 2022 award. The idea is to develop a simulation for training robots to care for elderly and disabled people. The simulation was created based on real data from research partners and provides many test tasks for robots under realistic conditions. Capture for Drones, Stanford University. The IROS Award for Best Paper on Robot Mechanisms and Design went to researchers from Stanford University, who developed a simple but fast and efficient drone gripper. The resulting grip is lightweight at 23 grams and closes in 12 milliseconds, and with it, a drone weighing 550 grams can capture a target weighing 85 grams at speeds ranging from 1 to almost 3 meters per second. Robot Artist Training, Seoul University, KAIST and Naver Labs. The IROS Award for Best Entertainment Work went to developers from Seoul National University, KAIST and Naver Labs. They jointly taught the robot how to draw through demonstrations, and that is, the machine relied not on simulated movements with estimation of the result, but on data from extensive collections of human demonstration. Which study did you like the best? Let us know in the comments. And while you're here, subscribe to the Pro Robot channel, like this video, and join us over on Instagram, where there's many more interesting things to come.